Alright, so this section is called Introductions to Functions. We're going to be talking about functions, we're going to do a little bit of graphing, and we're going to do a little bit of evaluating. So to start off, we have to talk about the definition of a relation. So a relation is kind of like a relationship among values. So again, that's why we call it a relation. You have a certain relationship between x's and y's, but we call them domain and range. So from now on, when you guys hear the word domain, it's just reference to the set of the x values, and range is the set of the y values. So let's go ahead and do an example real quick here. So here we have a relation represented by a set of ordered pairs, right? So we have a bunch of ordered pairs here. Now they're asking us to identify the domain and range. So pretty much like you just saw right now, right? The domain is just the set of all the x values. So I come over here and I just highlight the x value. So the x value in each ordered pair, I put them together, and that right there is my domain. And then the range is the same thing, but with the y value. So this one right here, the -8, the 3, and the -11, right? So just so you know that the difference between domain and range. So when we have ordered pairs, it's super simple to just identify your x's, identify your y's. Now, here comes the interesting part, and this is what you will be seeing a lot of. How in the world do I find the domain and the range if I'm just presented with a graph? So this is what you're going to do. So to find the domain, you're just going to stare at the graph and check how far the graph stretches to the left and how far it stretches to the right. So domain is how far it goes from left to right. Now the range, it's going to be the same thing, but instead of left and right, it's going to be down and up. And again, this makes no sense, but just we'll look at an example. So just remember, domain, how far does it stretch to the left and to the right? And then range is how far does the graph go down and up? So let's go ahead and try this out, right? So here we have a graph. So this is what we call a parabola, right? And this little point here is called the vertex. But we have the graph, and all they're asking us for is to find the domain and the range. So remember, for domain, it's all the x values, but we don't have ordered pairs. We have a graph. So to find the domain, we're just going to ask ourselves, how far does this graph stretch to the left, and how far does it stretch to the right? So again, the farthest left point seems to be this one. But just remember, this graph is going to keep on going, and it's going to get wider and wider. So it's going to get wider. And then this one is also going to keep going because it doesn't have a definitive end. If it had a little dot here, then that means, okay, that's the end. But it just keeps on going. So just pretend this graph is going to get super wide. So it's going to get fatter and fatter per se, right? So your domain is actually going to be from -infinity to +infinity, because this line is going to end up going all the way to that side. And then this line is going to end up being all the way to the right side. So this graph stretches infinitely to the left and infinitely to the right. So that's why my domain is -infinity to +infinity. Now, the range. Remember the range, if you look at the notes on the previous slide, the range is how far does the graph go down and how far does it go up. So this graph never passes more than this point. That's the lowest point on the graph. So that is where my range starts. Now we're going to look at remember, range is the y value. So what's the y value here? It's -2 point something. But again, they give us a dot. So this is my range, -2.25. That's the lowest point. And then how high does the graph go? The graph goes all the way, remember, it keeps on going. So the highest point is going to be +infinity, because remember, now the range is talking about the y values. So the lowest y value is -2.25, and the highest y value is going to be infinity. Okay, so that's how I get these 2 points. And then if you remember from a section that we already covered, the reason why we have a bracket is because this is a closed dot. So remember, closed dots use brackets. And then if this would have been an open circle, it would have been a parentheses. And then just as a recap, infinities, every time you have an infinity, you use a parentheses. That's why all of these here have parentheses. So again, if you had already forgotten that, make sure you put it on your notes. Open circles are parentheses, closed circles are brackets. And again, domain is from left to right, and then range is up and down. Okay, if you're still a little confused, that's okay. Let's go ahead and try this one. This one has a combination, if you notice, of a closed circle and an open circle. So let's see if we could figure this out. Okay, let's go ahead and start with the domain. Domain, remember, is left to right. How far does the graph go to the left? How far does it go to the right? Unlike the last graph that we just saw, this one does have a definitive ending. So this one doesn't keep going forever. So left to right, the leftmost point is right here. That's the point that is most to the left. So for domain, that is at -3. So my domain is going to be -3, comma. What's the rightmost point? The point that is most to the right is this one. The graph doesn't go any further to the right than this point, and that point is 1. So I'm going to put 1. So that's my domain. Of course, we're not done. I still have to enclose it with either parentheses or brackets. And super simple, we just remember, right? When we have a closed circle, we have a closed circle here at the bottom. So the -3 is going to go with a bracket. Again, let me put a little note here because of the closed circle. And then the 1 had an open circle, so that's going to be enclosed with a parentheses. And again, let me just go ahead and put a little note here. This is because of the open circle. So what do you guys think? I think that was pretty simple. That's the domain, the leftmost point and the rightmost point. Okay, let's go ahead and figure out the range. Range is the same thing. Remember, now we look at the lowest point and the highest point. So the lowest point is this one again, but now we don't look at the -3. Remember, range is your y. So we're going to look at the y. So the lowest point is going to be -5. Remember, you always start with the lowest point and then comma the highest point. Now, what is the highest point? If you're going to tell me, hey, this is the highest point, you are mistaken. That is not the highest point in the graph. And hopefully you see why, right? So let me go ahead and erase that. That's not the highest point. The highest point in this graph is this little dot right here, right? That's the highest point on the graph. The graph is never going to go higher than that. So we look at the y value there, and that's a 4. And now we have to enclose, right? So let's go ahead and look here. The -5, that's a closed circle. So we're going to use a bracket. And now I know what you're thinking, right? The 4, there was no dot there. So if there's no dot, if the graph just passes through there, and let me go ahead and erase that right now so you can see what I mean. There's no dot there, right, at all. So what do? When you have that, we pretend it's just a closed circle. So that means this is also going to be a bracket. So my range for this graph is -5, 4, because -5 is the lowest point and 4 is the highest point. So that would be my range for this one. If you're still a little iffy about this, just go ahead and keep on practicing. You're going to see a bunch of these on your homework, so be ready for those. All right, now let's go ahead and make this a little more interesting. Here we have somewhere in the graph, there's a closed circle, there's an open circle, and there's even a line that keeps on going forever. So let's see if we could figure this out. Okay, so again, domain is how far does the graph go left to right. So the leftmost point, if you notice, this one doesn't end, so this one's going to keep on going. So it's going to keep on going, so it's going to go forever to the left. So it goes all the way to infinity, but remember, to this side, it's actually -infinity. So the domain is -infinity, and then if you remember, infinities always go with parentheses, comma, what's the rightmost point? We already did the left. What's the rightmost point? So let me go ahead and continue the graph. This graph goes like this, and then it stops right here. It doesn't keep on going because there's an open circle. So let me go ahead and erase that real quick, just so you know it doesn't keep on going. Now, since that's the rightmost point, this is where we're going to stop. But what number do I use? Do I use the 3 or do I use the -5? So remember, since we're talking about domain is x. So I'm going to come to the x-axis. This is the point that it goes most to the right, and then that's 3. So that means that that's where the domain ends. And then since it's an open circle, we enclose it with a parenthesis. So again, let's go ahead and just verify that we did it correctly. Domain is left to right. This graph is going to keep on going forever to the left side. And if your question is, why did she use the -infinity if it's going up? Remember, domain is the x-axis. So we're only looking at this right here. So it's going to keep on going forever to the left. Remember, domain is left to right, not up and down, just left to right. So it's going to keep on going forever to -infinity. And then this one stops at 3. So that's how we got our domain. So let me go ahead and erase this real quick because now we're going to do the range. So domain was left to right. Now range, remember, it's up and down. So let's go ahead and start in the down. You always start down. So range, what is the lowest point on this graph? So let me go ahead and just draw it. The lowest point, hopefully you agree with me, is this one. And remember, range is y. So now we don't look at the 3, now we look at the negative 5. So this is the lowest point. The graph goes all the way to negative 5. And since it's an open circle, I'm going to enclose it with a parentheses, comma. Now, what is the highest point? So let me go ahead and draw the graph. It looks like, okay, I know what you're saying. It looks like this is the highest point, right? Oh, that's the highest point on the graph. But remember, this line keeps on going forever. So eventually it's going to go higher than 4. So 4 is not my highest point. My highest point is going to be, what do you think? If this line keeps going forever, it's going to cross 4, it's going to cross 5, it's going to cross 6, and it's going to cross all the way to positive infinity. Okay, so this is going to go all the way to positive infinity, and then infinities always go with parentheses. All right, I feel like I might have lost you here, so let me just go ahead and rephrase that, right? Since we're talking about range, we're talking about up and down. This is down, which goes negative 5, and then it's going to go all the way up to, remember, we're looking at the y's now, so this is going to be all the way to positive infinity. Okay, I know what you're thinking. She just said it was negative infinity a couple seconds ago because we were talking about domain. Okay, so I'm going to go over that just really quickly again, but those are my answers for domain and range. So again, for domain, you look at the x. All the way over here, we have negative infinity. That's why we had a negative infinity here, because it keeps on going to the left to negative infinity. Now for range, we're talking about up and down. So this one keeps on going. And since we're talking about up and down, we're looking at the y. That's why we had a positive infinity. Okay, because this one goes up that way. So I'm hoping that made sense. If it didn't, again, just let me know. I will come up with a different example and we could work on it together. All right, since we know about domain and range, now we are going to learn how to identify if a relation is a function or not. In order for a relation, and we already talked about relation, right? It's a relationship between values. In order for a relation to be a function, each x coordinate has to have only one y coordinate. Okay, I know that makes no sense. Don't worry about it. We're going to do an example. But just remember, this is the definition of a function. In order for a relation to be a function, each x-intercept has to belong to only one y coordinate. X coordinate to one y coordinate. So this is what I mean. Let me go ahead and give you an example. So here we have an example of a function, right? This little, these are your x's, hopefully you remember, right? X's are always the first numbers in ordered pairs. And then these are my y's right here. So that's a y, this is a y, and this is a y. This is an example of a function because look at this. The 1 belongs with the 2. The 3 belongs with the 4. And the 5 belongs with the 6. There is no x-intercept here that wants to have more than one y-intercept. So this qualifies to be a function. On the other hand, this one is not a function, and hopefully you see why. This x belongs to this y. So the 1 belongs to the 2. That's okay. But then look at this here. This 1 also wants to belong to a 4. That's why this is disqualified, because the 1 should only have one y coordinate. The 1 we already said belongs to the 2, so it cannot belong to any other number. It cannot belong to 4, and that's why that is not a function. This one here actually doesn't give us any trouble. That's okay. It's these two that let you know that this is not a function. Again, because the 1 wants to belong to a 2 and also wants to belong to a 4, which is a big no-no. So in a function, it's supposed to be a nice relationship, right? One value cannot be going to two different values. Okay, so I'm hoping that made sense, but if it didn't, don't worry. We have a couple more examples here. So here's a question. Is this a relation, is this relation a function or not? So go ahead and stare at it. What do you think? Is this a function or not? Again, in order to double check, go ahead and look at the x values. Here we have a 3. Here we have a 15. Here we have a negative 22, and here we have a 19. right off the bat, you should see that this is a function because the x-intercepts, or sorry, the x-coordinates do not repeat. So we're not going to have any trouble here because the 3 has its little pair, the 15 has its little pair, the negative 22 has its pair, and the 19 has its pair. This is a perfect example of a function. This does not violate the definition of a function. So every x value has its little y. I know there's a number in there that repeats, but as long as the x's do not repeat, we're okay. All right, let's go ahead and try one more. Is this a function or not? What do you think? So hopefully you are able to see that this is not a function, right? Again, the one, these look okay. The one that gives us trouble is this one and this one. Again, the reason why is because the negative 2 belongs to the 7. And then over here, the negative 2 also wants to belong to the 9. So that's a big no-no. So you cannot cheat on your little y-intercept, right? So on your y-coordinate. The negative 2 has to belong to only one y value. And it wants to belong to a 7 and it also wants to belong to a 9. So that's how you determine that it's not a function. All right, hopefully that made sense because now we're going to move on to how do you check if a graph is a function or not? So if I give you a graph and ask you, hey, is this a function or not? This is how you're going to find out. The definition might seem a little confusing, but once we do an example, you're going to see what I mean. So the graph of a relation represents a function if you cannot draw a vertical line that will intersect it more than once. Okay, so a function has, for a function, you cannot draw a line that's going to intersect it more than once. So here we have two examples. One of them is a function and one of them is not. So let's go ahead and determine which one is. So what do you do, right? Pretend you open up your homework, you open up your test, and you see this graph right here. All you're going to do is draw a line. It has to be a vertical line. This line intersected the graph only one time. So that's okay. But to make sure, let's go ahead and draw another one. This one only intersected it once. So we're still okay. But just because I want to make sure, let's go ahead and draw another one. This one only intersects once. So since it only intersected once, this is a function. So I'm going to put, yes, it's a function. So hopefully that made sense. You could draw a bunch of lines, and I'm going to exaggerate. Any single line you draw in this graph is only going to intersect the graph once. So that's why this one is a function. Now let's go ahead and try this one. This one, if I draw a line right here, okay, I totally messed that up. Let me go ahead and draw one. It has to touch the graph. Here we go. I intersected the graph just once. So, hey, it looks like a function, right? But if I draw another line, what happens? Uh-oh, it intersected the graph 2 times. So as soon as that happens, you don't have to draw another line. This one's already disqualified. So this is not a function. Okay, so again, what you're going to do is when you see a graph, all you have to do is draw vertical lines. That's the thing though, it has to be a vertical line. Draw a vertical line. If it only intersects it once, then it's a function. You're good to go. But if you draw a line that intersects 2 times or more, just like on this one, then that's it. You just drop your pencil and be like, ma'am, this is not a function. Okay, so let's go ahead and put this to the test. Here is a graph. It's a blue line, right? Is this a function or not? What do you think? So I'm going to start drawing lines. So here's one line. It intersected once. Here's another line. It intersected only once. Here's another line. It only intersected once. So as many lines as I draw, they all intersect once. So is this a function? Yes, right? Again, it doesn't violate the rule. Let's go ahead and try this one. Is this a function? I draw a line. It only intersects once. So it looks like it is a function. I draw a line. It only intersects once. I draw a line. It only intersects once. So I know what you're thinking, right? Oh, she's not making this interesting. So let's make this interesting. I draw a line here. What happens? It intersected 1, 2, 3 times. So even though the first 3 lines looked okay, as soon as I drew this one's the one that gave me trouble. So is this a function? No. Okay, so again, I know I'm exaggerating. I'm drawing like 4 lines. You could just go straight to a line in the middle. And since intersected more than once, then this is not a function. Okay, last one here. Is this a function or not? Let's go ahead and draw a line. This one only intersected once. A line here, once. A line here, once. Okay, I already got tired of drawing lines. Hopefully you got the idea, right? As many lines as I draw, they only intersect once. So is this a function? Yes. Okay, so the graphs could look very weird, but again, it's always the same test. It's called the vertical line test. Draw a vertical line, ask yourself how many times does it intersect, and just remember, if it intersects more than once, then you could right off the bat say it's not a function. But this one was, right? All right, the last part of this section is how to evaluate a function. So once you determine something's a function, right, I could write it down as a equation. So for example, here I give you an equation. And if I ask you to evaluate, all you have to do in order to evaluate a function is that you're going to replace the variable with a number, and you're going to simplify. I totally misspelled it here. So simplify. Go ahead and fix it on your notes. Simplify. Right, so to evaluate a function, you just replace a variable with the number that I give you and you simplify. So if I ask you, evaluate the function, which is right here, when x equals 5, all you have to do is put that number in the variable and simplify. So instead of the x, I'm going to replace it with a 5, and then I just simplify, so 5 plus 2 is 7. So that's all you're going to do. So when you see a problem that says evaluate the function, just replace it and solve it or simplify. So let's go ahead and try this one here, right? So evaluate f, and the way you guys read this is f of -9. It's always f of whatever's in there. So all I'm going to do is I'm going to get this little thingy. I'm going to replace it. You get the idea, right? We're going to replace it on the x. When you replace something or substitute it, always do it with parentheses, please, because if you don't, you'll make a mistake. So I replace the number into the x. So instead of x, I put -9 in parentheses and then squared. And then the reason I told you to put parentheses, and try it. If you have a calculator, try putting it without parentheses and then try it with parentheses, and you will probably be getting different answers. So when you replace a -9, put it with parentheses and then you just simplify. So -9 squared, we know it's -9 times -9, so my answer is 81. Now, there's two ways to write your answer, and I want you to write both ways on your note packet because it depends on how I ask you for the answer. You could simply put 81, right, because that's the answer, but I want you guys to get used to this. This is the fancy notation. We always like to write our answers as ordered pairs. The first value is the x value that you substituted, which was -9, and then your y value is the answer that you got. Okay, so again, this is allowed, but on your homework, I'm pretty sure they're going to want you to input this. And on your test, this is what I want to see. Okay, so let's go ahead and try a few more. Evaluate f of -3, and I give you the equation. Again, all you have to do is put the -3 on the x. But keep in mind here, this function has two x's, so you're going to have to replace it on both of them. And again, make sure you put it or substitute with parentheses. So if you notice, I put parentheses, 9 times -3 squared plus 2 times -3 minus 2. If you notice, everything stays the same, just the x's take on the value of -3. Now, according to the order of operations, I have to do this first, right? Please do not multiply 9 and -3. According to PEMDAS, I have to do exponents first. So -3 squared gives me 9. And then I went ahead and did this one too. So 2 times -3 gives me -6 or -6. Now I have to do 9 times 9, which gives me 81, and everything else just comes down. And then I could simply calculate this, right? 81 minus 6 minus 2 gives me 73. Now, how do I properly write down my answer? Hopefully you remember. The first number is going to be the number I substituted, which was -3. And then the second number is the answer that I got. Okay, that was pretty simple. All right, evaluate -x squared minus 23 for f of 7, right? So we're going to have to evaluate this. Again, the 7 goes in here. And the reason I chose this problem is because I want you guys to be very careful with your negatives. So all we're going to do is replace the x. If you notice, the 7 just replaced the x. The negative is still outside the parentheses. So be very careful with that. So let me just go ahead and go back to the last problem. On this one, The negative was inside the parentheses, so when I replace it, I put in my calculator -3 squared. Now in this new problem, the 7 goes alone inside the parentheses and the negative goes outside. So 7 squared gives me 49, and the negative, if you notice, just comes along. Okay, so it doesn't become a positive, it's still there. So 7 squared is 49, the negative is still there, the minus 23 is still there. So now the last thing I have to do is just -49 minus 23, which is -72. And like I told you, to practice over the, I didn't put this here, but make sure you put it on your notes. The final answer should be 7, right? Because that's the number I input in, comma, -72. Okay, so make sure again, if the test tells you write your answer as an ordered pair, make sure you write it as an ordered pair, which would be this right here. All right, I believe we only have 2 more to go, so let's go ahead and try this one. This is where it gets even better, right? Because I don't give you a function, I just give you a graph. You guys, these are super simple. Evaluate f of 3. So all you're going to do is that this number is going to be your x. So I come to the x-axis, which is this right here, right? This is my x-axis. I look for the number 3, which is right here. And then I look at the graph. The graph right here at 3 is what value? Oh my goodness, I was supposed to circle it. There you go. So my answer is just 2, or like we already know how to practice, the x value, comma, the y value. Okay, so what do you guys think of this? So again, when we don't give you a function, when we give you a graph, you just look for this number on the x-axis. So I look for it here. And then I look at my graph, which is right here at the point 3. So this is 3, and then I look at the y value, which is 2. And again, make sure you practice on writing your answer as an ordered pair. All right, the last one for this section, go ahead and enjoy it, right? So -2. We look for it on the x-axis, which is right here. But then we look at the graph, and the value right here is 1. So my answer is 1, or of course the fancy way we want to write it, -2, comma, 1. Okay, so I'm hoping this made sense. I know there was a little bit of everything in there, but if there's anything that lost you, just make sure to reach out to me and I could give you more examples and we could continue reviewing.